Smartwatches are becoming increasingly popular among mobile users. But selecting small targets on smartwatches remains a challenge due to the fat finger problem. We propose a force-based approach to facilitate the selection of small targets on smartwatches. To map the most comfortable range of force to cursor movements, we conducted a study to identify the levels of force users can comfortably apply on smartwatches. Participants were asked to perform soft, regular, and hard taps on the screen. Results reveal that the median force applied for soft, regular, and hard taps were 0.1, 0.39 and 0.55, respectively, on a scale of 0 to 1. We used the range from 0.05 to 0.80 as the range of our mapping function, which are about 1 standard deviations from the medians of the two extremes. The values between the range were then mapped to the 368 pixels horizontal space of the smartwatch using a linear function. We then conducted a one-dimensional Fitts law study to compare the performance of tap and force tap in target selection tasks. We used widths 10, 40, 80 pixels based on the optimal widths recommended in the literature. We used amplitudes 80, 140, 200 pixels to make sure the targets do not overlap or go outside the boundary. In the study, participants selected targets on the two sides in a back and forth order by either tapping or variating contact force. Reducing the force moved the cursor to the left and increasing it moved it to the right. Results revealed that force tap is significantly better in selecting smaller targets, while tap outperforms force tap for bigger targets. We designed two, slide and force, keyboards to demonstrate practical usage of force input. The keyboards occupy a small area of the screen and enable entering one character at a time using force tap and finger slide gestures. To enter a letter with slide force keyboard, slide the finger horizontally, closer to the target letter. Apply soft or extra force to select the target on the left or right of the magnified view, respectively. Release touch to enter the highlighted letter. To enter a letter with slide force slide keyboard, slide the finger horizontally, closer to the target letter. Apply extra force to replace the keyboard with a magnified view. Slide the finger to the target letter. Release touch to enter the highlighted letter. We compared the two keyboards in a user study. Results showed that entry speed of the two methods yielded about 4 words per minute with about 2% error rate. A significant effect of learning was observed even in the short duration of the study. Besides, most participants liked the methods and felt that their performance with these will improve over time. These results demonstrate the viability of using force to select small targets on smaller screens. In summary, the findings indicate that force input is more effective in selecting smaller targets than touch on tiny screens, and could be effectively used in practical scenarios.